Polar bears and polar cubs, it's time for percent composition. So it's really percent by mass of the elements within a compound. If you ever think that you can't find the equation or remember it, it is on the back of the periodic table. So really what percent composition does is it tests your molar mass, calculating skills, and then composition of it. So anytime within a sample problem or a problem, if it says percent composition, it's asking you to show the work to find the percent of copper and or of each element within the formula. We do not, I repeat, we do not do the, hey, I found this percentage, I take 100 minus that to get the other. I want to see all the work. So, first part is writing the formula. Copper 1 sulfide. Sulfide is sulfur on the periodic table, which has a -2 charge. Copper here has a +1 charge. So we crisscross it. You're going to get CuS or Cu2S. So we're going to calculate the gram molar mass of this. So molar mass of copper is 63.55. There's 2 of those, so we're going to multiply it by 2, giving us a grand total of 127.10. With sulfur, it is just 32.07. Added up, this is going to give us the mass of the entire compound of 159.17. So this is a percent composition just based off of molar mass. So what we'll start with is for copper percentage, you're going to take the mass of copper, which is 127.10, over the entire compound of 159.17. We're going to take that answer and multiply it by 100, and we're going to get our percentage. So 127.1 divided by 159.17 times 100, and you're going to get 79.85. Now, all of the percentages, I'm going to ask you just go to 2 places behind the decimal place. Then we're going to have the unit of percent, and then the label or ID of copper for that one. And then we need to do it for sulfur. So sulfur, you're going to take S percentage, the mass of sulfur, which is 32.07, over the total mass. Times 100. So we're going to get 32.07 divided by 159.17, and you get 20.15% sulfur. And if you add those up, they do equal 100. All right, I'm going to have you guys try sample problem number 2. And then sample problem number 3 is a little bit different, and we'll go over that together. All right. We'll talk about some answers here in 3, 2, and 1. So for problem number 2, it's sodium carbonate decahydrate, meaning 10 waters. Sodium has a +1 charge, carbonate a -2 charge. So it is Na2CO3 with 10 H2Os. So in this problem, we're just simply asked to find the percentage of water. So we're just going to find water percent. Okay, so we need to find molar masses first. So 22.99 is sodium times 2 plus 12.01 for copper or carbon plus 48 for the 3 waters, and you're going to get 105.99. Now, this is the sodium carbonate section of that compound. 16 for oxygen plus 2.02 for 2 hydrogens, giving you 18.02 times 10, since there's 10 waters, and you'll have 180.20. You'll add those together, and your molar mass for that entire compound is 286.19. So the percentage of water within that compound, you're going to have the mass of water, which is 180.20, over the entire mass, 286.19. We're going to multiply that by 100, and that's going to give our percentage. And our percentage should be 62.97%. Now, for water, when you type it into the assignments, you can put H2O because you can't put subscripts, or another way that we write water is HOH. So let's talk about sample problem number 3. It's also a percent composition problem. However, this one is based off of like lab data. So you have a carbon oxygen compound with a mass of 95.2, 40.8 grams of carbon. So 40.8 grams of the 95.2 is carbon. We want to find the mass, the percentage of oxygen. So what we want to do is, if this is grams of not only carbon but also oxygen, we're going to subtract the mass of just carbon, and we'll get the mass of oxygen. So 95.2 subtract 40.8, and we're going to get 54.4 grams of oxygen. So in order to find the percentage, you're going to take oxygen percent would be equal to 54.4 over 95.2 times 100. And that gives you a percentage of oxygen within that compound of 57.14%. Oh, notice how I still went to 2 places after the decimal, even though we only have 3 digits in here. So for sig figs, when dealing with percentages, we are always going to go to 4. All right, that's percent composition. If you have any questions,